Welcome in. In this video, we're going to go over some pretty basic Ethernet concepts. And when I say some pretty basic Ethernet concepts, we're going to talk about the history of Ethernet, where it came from and how it got to be the most widely used networking system in use today, and how Ethernet works at a very basic level. Now again, this is the CCENT course, so if you're looking for a course that can tell you all about how Ethernet works on the wire and how every little bit in the frame works, this really isn't the course for you. There's all kinds of websites and other video courses that you can take where you can learn everything there is to know about layers 1 and 2. This is not part of the CCENT curriculum, and so we won't be covering it in this course. So we'll start off with the history of Ethernet. Ethernet has been around since the middle 1970s, and the middle 1970s, 73 and 74, is when some pretty smart guys at DEC, Intel, and Xerox got together and came up with the protocols that would make up Ethernet. And they published those protocols in a white paper in 1980. And like any good idea, they found improvements to these ideas that could make networking a lot easier, and so in 1982 they released version 2 of these standards, and it became the basis for Ethernet 2. If you open up an Ethernet capture in Wireshark, which we will do elsewhere in the course, and you look at the frame type of a packet, you'll see that it comes across as Ethernet 2, and this is why it's called Ethernet 2. The IEEE took the Ethernet 2 standard and published it as the 802.3 standard, and the IEEE stands for the Institute for Electrical and Electronics Engineers. Now, as I alluded to a little earlier on in this video, Ethernet encompasses both OSI layers 1 and 2. It not only contains standards of how the electrical impulses physically go across the wire, it also has the data link and media access functions built into the protocol. And as we discussed when we talked about the OSI model, when it comes to Ethernet, layer 2 is divided into two sublayers. Now, the MAC sublayer controls physical access to the wire, and again, that's the MAC address. The LLC sublayer indicates what layer 3 protocol is in the Ethernet frame. Now, this is a little different between Ethernet and Ethernet 2, and at the very end of this slide deck, I have a picture of an Ethernet frame, or the layout of an Ethernet frame, and you'll see the differences between the raw Ethernet and the Ethernet 2 frames. So let's talk about Ethernet cabling. Way back in the dark ages, the very first Ethernet cables were 10-base-5, referred to as thick Ethernet, and I've got a picture of it here. People that I know that have worked with this basically called it a frozen garden hose because that's about how pliable this particular networking topology was. Basically, your network segment consisted of one long coaxial cable running the length of the building or the length of the floor or between all the computers in an apartment. And it used vampire taps, which is this device you see over here. And what you can't see inside of this is it's got two little fangs, if you will, that pierce down into the wire. One pierces into the outer shell, one pierces down to the middle of the coax, as you see right here in this picture. And in addition to being rather unwieldy, you had this one long coax cable that if someone tripped over it, or if someone rolled their chair over it, or if it broke, or anything, you took down the entire network segment just from one little break in the cable. And I've not ever worked on a 10-base-5 Ethernet network, but I have worked on its successor, the 10-base-2 thin Ethernet. And really the only difference is that the coax cable is a little smaller. It still runs from one end of the building to the other, or one end of the department to the other. It's just instead of the vampire taps, you have this little T connector here. And if you were to go behind one of the computers and just unscrew one of these coaxes from the edges of the T here, you'd take down the entire network, especially if it's a small network where the cable goes from one end of the building to the other. You unscrew that and the entire network goes down. You roll your chair over it, the entire network goes down. It's got all of the problems of the thick Ethernet cabling, but it's a little easier to deal with. Again, about the only nice feature between 10-base-2 and 10-base-5 was that it used these T connectors instead of the vampire taps. So then we'll move on to modern day. Modern day is 10/100/1000 base T, depending upon the speed of the network, anything from 10 megabit up to 1 gigabit. And there are ways you can do 10 gigabit over copper in some of the really high-end Cisco switches, but for the purposes of the CCENT, you're just going to assume that the fastest you'll see on a copper wire is gigabit Ethernet. Now, the most common or the most popular media you'll see is the twisted pair type of media, which you see in the picture over here, although obviously you can use fiber optics as well. And of course, we won't get into that in this course, just simply because we're going to assume that everything you'll run into is gigabit Ethernet running over RJ45 twisted pair. We'll pick up our discussion of Ethernet concepts in the next video.